Okay, so this video is to address problems 9, 13, and 25. So 9, 13, and 25. All right, so this says, for a standard normal curve, find C. So remember that a standard normal implies the zeros in the middle and the standard deviation is 1. That's just critical to remember. And then it says, find that C is a Z such... We're looking for C, that Z is less than C, and that probability is 0.5053. So just note, if C was at 0, the probability to be less would be 0.50. So the fact that it's just barely over 50%, C is going to be somewhere right here. So it should be a pretty small number, like close to 0. Find C rounded to 2 decimal places. So I'm going to use some technology. Again, I'm going to stick with the 84. It's what I recommended in the syllabus. If you absolutely can't get one, you can use Excel. If you're going to use Excel, the code that you would use for Excel is norm.inverse. I think it's nv.norm for Excel. But for the TI-84, you're going to hit the second key to the vars. That takes you to the distribution page. Then you're going to choose inverse normal. It's going to ask you for an area to the left of the number you want. You're going to put in this 0.5053. And you want a standard normal curve, it will ask you for a mean, you're going to put 0. It's going to ask you for a standard deviation, you're going to put 1. And when you hit enter, you're going to get the answer that you need for that. So I'll do it real quick so you can check your answer with mine as you're doing this, just to make sure you're punching the numbers right. Again, second, I need to charge my battery. Second bars. Inverse normal is number 3. 0.5053 left of the tail, 0, 1 left paste. Enter. Like I said, it's a number really close to 0, 0.0132. So 2 decimal places would be right there. Okay, so that's number 9. Let's take a look at 13. All right, so this one, before they gave us a percentage, a decimal, and they asked us for a cutoff. And this one, it looks like they're asking us to find, well, let's read it. Assume the readings of freezing on a bundle of thermometers are normally distributed with a mean of 0 degrees and a standard deviation of 1. So they have a standard normal curve. So that's the first thing to kind of just realize is that they have a standard normal curve. Okay. And then it says, a single thermometer is randomly picked and tested. Find the probability of obtaining a reading that is greater than negative 1.74. So if they have a 0, 1, and we're looking here at negative 1.745, and we want this area under the curve here. When they're giving you cutoffs and you're looking for areas, you're going to use normal CDF. So same. If you're using Excel, it's normal.dist. All right. So you go to second vars, which is your distribution button. You're going to choose normal CDF. So second vars, normal CDF is number 2. Lower limit, you need negative 1.745. Upper limit, you want a really, really big number. So take a 1 and then just put a whole bunch of zeros after it. And that will be big enough because you're basically looking at towards infinity. 0, 1, and paste, hit enter. And this is going 0.9595. All right. 95950. All right, then that's to 5 decimal places. I'm sure you don't need that many decimal places on that. And the last requested number was 25. Okay, so I moved to the coffee shop, so the background noise might be a little bit not so great, but I'm waiting for an appointment right now. So we're on number 25. All right, so it says the wingspans of adult herons are approximately normally distributed with a mean of 123 and a standard deviation of 13. So we have a mean of 123, standard deviation of 13.4. All right, it says determine the proportion of herons that have wingspans less than 86. They give me a cutoff asking for an area. So this is going to be normal, CDF. And our lower limit's going to be negative infinity. Our upper limit's going to be 86. Our mean is 123, and our standard deviation is 13.4. So you're going to put that information in. If your calculator doesn't take a negative infinity sign, you're going to use -1 e to the 99, or -1 with a whole bunch of zeros. You can just throw a bunch of zeros in. It doesn't take that many before you are going to be accurate to the nearest, whatever, 20th place style. The largest 5% here is largest 5%. So they're giving us a percent and asking for a cutoff here. Largest 5% is the same as the bottom 95%. All right. So when they ask for an area, you're going to put 0.95. Again, your mean, your standard deviation. They're giving us a percent, asking for a cutoff. So this is an inverse normal. Middle 90%. So the middle 90% is the same as finding the top 5% and the bottom 5%. Hey, fun fact, that should just be middle 90%, top 5%, bottom 5%. That should be just whatever this number was, positive and negative, or not. No, that's not true. In a standard normal curve, it would be whatever that was, positive, negative. You're going to have to do the top 5%, 95, and then the bottom 5%, same thing, inverse normal, use the area of 0.05. Determine a proportion who have wingspans between this. This is a normal CDF. And they're going to ask for a lower limit. You put 106, upper limit 48, and then your mean and your standard deviation. Proportion which have wingspans greater than. So now your lower limit is 160. Your upper limit is going to be just a really, really big number. Awesome. Infinity, if you have a calculator, it takes infinity. And then your mean of 123 and your standard deviation of 13.4. And the smallest 15%, again, they've given us a percent asking for a cutoff, so this is going to be an inverse normal. All right, hopefully this is helpful. I will be online tonight for any questions, so feel free to come on and Zoom on. Thanks. Have a great time.